Alright, students, momentum is always a confusing term for students. Momentum is given by P equal to m into V. Force is directly proportional to rate of change of momentum. And as velocity is correlated with acceleration, so also momentum is correlated with force. This is the first thing. Now, just right now, don't look around your surrounding to find momentum, because it is very difficult to understand momentum in our daily life. Now, after understanding this conservation of momentum, you would easily able to find out that okay, this thing should be called momentum. मैं उसे कॉमन वर्ड्स में झोंका कहता हूँ. ओके, सो फॉर एन एग्जांपल, आप अगर जैसे दरवाज़ा खोलना है उस और वो बिल्कुल जाम हो रखा है, तो यू स्लाइटली रन एंड देन किक द डोर. तो उससे क्या होता है, यू गेन सम मोमेंटम एंड देन इट गेट कन्वर्टेड इनटू अ काइंड ऑफ फोर्स. तो हम ये कह सकते हैं कि फोर्स का रिलेशन मोमेंटम से है. फोर्स लगने के बाद मोमेंटम का स्टेटस चेंज हो जाता है, मास इनटू वेलोसिटी का कॉन्सेप्ट चेंज हो जाता है. कॉन्सेप्ट नहीं, उसका स्टेटस स्टेटस चेंज हो जाता है. वो बढ़ सकता है, वो घट सकता है. ओके, सो कंजर्वेशन ऑफ मोमेंटम, पहले हम इसका स्टेटमेंट देख लेते हैं. द डेफिनेशन इज, फॉर एन आइसोलेटेड सिस्टम net momentum of the system remains conserved. What is this isolated system? Isolated, alag thalag, separated. So for isolated system, external force is zero. There's no external force. So right now, if I am applying a force, so it is, this pen is not an isolated system. But if I also consider myself as a system of my hand and this pen, now whatever I am doing, it is within this system. Now no external force is being applied. Now if I apply force, additional force, now this is extra force. And if I also consider this as a part of this system, now, all right, so it depends upon us how much system we are considering. But generally what happen, we have to take an isolated system where external force is zero. Okay, so net remains conserved means remains same. Actually, these technical terms are difficult to handle. Remains same, remains constant. This is the law of conservation of momentum. How is it possible? So we know proof that according to Newton's second law of motion, F is equal to, actually directly proportional to, but we can directly use this part. F is equal to delta P upon T. Now for isolated system, isolated, okay, separated, not connected to any other, F equal to 0. So 0 equal to delta P upon T. Cross multiply this T here, so we will get 0 equal to delta P. What is delta P? Change in momentum. That is, change in momentum equal to 0. What is change in momentum? Final momentum minus initial momentum equal to 0. Now take it on other side. So final momentum is equal to initial momentum. It means momentum remains conserved. Momentum remains constant. So this is the law of conservation of momentum. For an example, let us consider a gun. Don't laugh at my drawing. Okay. It has a bullet. Now, when bullet is not fired, okay, mg is mass of the gun. I'm writing it capital M. And mb mass of the bullet. Now ug initial velocity of gun, which is 0. ub initial velocity of bullet, it is also 0. Initially entire system is 0. So initial momentum will be mass into velocity, mg ug plus mb ub. M into 0, m into 0, it will be 0. Next, mg mb, okay, vg is something, it is non-zero now. Actually vb is non-zero, so we have to check whether vg will do something or not, because when we fired the bullet, okay, trigger is pressed, so bullet is fired. Okay. Now this is the velocity of bullet, vb. We have to see whether it will move or not. We have just marked it vg. Maybe it will be 0. Let's see. So vb is something, it is right, huh? Don't think it means it is non-zero, it has some value. So final momentum will be mg vg plus mb vb. And according to law of conservation of momentum, it is an isolated system. Yeah, you can say that we have pressed the trigger, but it is just a mechanical thing. Actually, we are not pushing the entire gun in forward direction or kicking it or hitting it by something else. We are just changing the configuration of this. We have just pushed this trigger, I mean changed the configuration of this into this. For that isolated system, it means that there's no external force which is making this system to move. It is not making this system to move. It is just a mechanical arrangement. We are changing that mechanical arrangement, and due to which that bullet goes off. It is totally its internal matter. So according to conservation of momentum, final momentum equal to initial momentum. Now onward, I will write final momentum as pf and initial momentum as pi. So final momentum is mg Vg plus mb vb, and initial momentum is 0. So what will happen? Mg Vg is equal to minus Mb Vb. So Vg is equal to minus Mb Vb upon Mg. Negative sign shows that the gun will move backward. Don't you need not to remember this formula. If you can, that's good, but you have to just follow these instructions. Initial momentum will be 0, final momentum, you can remember this: mass of gun, velocity of gun equal to negative of mass of bullet, velocity of bullet. So you people might say that it is action reaction. Well, actually, action reaction is correlated with this conservation of momentum. In action reaction, still, it is the matter of two things. Like in rocket propulsion, what happens? Its combustible substance goes downward and rocket goes upward. So what happens? We can say that combustible substances are making a force downward action, and the reaction of it, rocket is going upward. And in other way, we can say these combustible substances ejecting out with some momentum. So initially rocket was at rest, zero zero momentum. So to cover up that momentum, if ejected fuel is going down, it will go up. There are several other examples of conservation of momentum. You need to figure them out. I will tell you few of it. Like in carom, when you strike a stationary coin with same type of coin, then you would observe that it comes to rest and other coin moves off to conserve the momentum. All right, so there are several other examples. Find them out, let me know. Bye bye.